In this lesson, we're going to take a look at simplifying with giant ones. So a few examples of this. If I have x divided by x, that is going to equal 1. We call it a giant one because the numerator and denominator together make a 1, which leaves a 1 over a 1, and 1 divided by 1 equals 1. Same thing with y divided by y. That also makes a giant 1, so this equals 1. So how does this help us with some of these other problems? So let's take a look at the next set here. If I look at x to the fourth over x to the third, and I had talked about this in a previous video, this actually represents, x to the fourth represents 4 x's being multiplied together. It's repeated multiplication. X to the third is the same thing. It is 3 x's being multiplied together. So now if I use the idea of giant ones, these two right here will become 1 over 1. These will become a 1 over 1. And these will become a 1 over 1. Which means in my numerator I have 1 times 1 times 1 times x. And my denominator is 1 times 1 times 1. All of this, 1 times 1 times 1 times x equals x. 1 times 1 times 1 is 1. And we actually don't need to write a 1 in the denominator, so all that simplifies down to is x, which you can see right here. There's 1x left. The future problems, I'm going to skip this step right here because it's just want to show what happens with all the variables, but we really don't need that step. So in the next problem, x to the third divided by x to the fourth. So I have the same type of numbers as the last one. I've just flipped them, used the reciprocal. So again, the numerator, x to the third, that's the same thing as x times x times x. The denominator, x to the fourth, will be 4 x's multiplied together. So it looks like that. Now using my giant ones, giant 1, here, and here, which means in my numerator, the only thing I have left now is a 1. In my denominator, I just have x. So x to the third divided by x to the fourth is now 1 divided by x. Let's take a look at another example. Now I have a couple different variables, x to the third, y to the fifth, over x times y to the eighth. Well, if I write out x to the third, it is x times x times x. Y to the fifth is going to look like that. There are 5 y's being multiplied together. In the denominator, I have x, and then I have y to the eighth, which are going to be 8 y's. So thinking about making my giant ones, with my x's, I make a giant 1 there. I still have 2 x's left, so that is x squared. Looking at the y's, I make a giant 1 here, and here, and here, here, and 1 more, leaving me with 3 left in the denominator, which is y to the third. So this problem simplifies down to x squared y to the third. Going into the next problem, which I just jumped ahead too quickly, but here's the next problem. Now, not only do I have variables, a couple of them, but I also have numbers. So I'm going to write this out and still use the idea of giant ones. 10 is the same thing as 2 times 5. X to the fifth and y squared is written out like that. Everything in the numerator is being multiplied. In the denominator, I have a 6, which can be written as 2 times 3, x to the third, y to the seventh. Again, if I use the idea of giant ones, 2 divided by 2 will be my giant 1. So if I start thinking about my answer, I have a 5 in the numerator and a 3 left in the denominator. So just from simplifying the 6 over 10, that simplifies down to 5 over 3. Now looking at the x's, making my giant ones here, I have 2 left in the numerator, which is x squared. Looking at my y's, I have 5 left in the denominator, which is y to the 5th. And that's how you simplify that. This idea is actually going to lead to some higher level ideas with exponents and laws of exponents, including zero exponents and negative exponents, which I will cover in a different video.